Hey everyone, I want to thank you for tuning in to one of EPARTRADE's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode.
Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistics, Feria Racing Component, Peak, Fifth Third Bank Motorsport, Quarer, and CTEC Manufacturing. I am Francisque Savignan, the founder and CEO of EPARTRADE, the racing industry, every minute, every day. This is episode 553, and we're going to be talking with Daido Metal and Robert Yates Racing. With me this morning are Judy Kin, the co-founder of EPARTRADE, and wonderful host, Mr. Brad Gillie. Judy?
Thank you, Francisque, and thank you everyone for joining today. We are so excited to have Daido Metals on today, along with the powerhouse of Robert Yates Racing Engines, who we all know have won multiple championships and many, many wins. So we're excited to have them on. Brad?
Yeah, very much so. And welcome back, Francis. Great to see your face again. So this is going to be awesome. Thank you very much, Francis. Thank you very much, Judy. We'll be talking to you again at the end of this webinar. But this is an exciting one. I was able to spend some time yesterday with Dustin and David and really talk about something pretty cool that we don't always get to talk about. We'll explain more here in just a moment. But our topic today, the title, The Benefits of Daido Main Bearings with Robert Yates Racing Engines by Daido Metal, featuring Dustin Kull, account manager of Racing and Aftermarket of Daido Metal, and David Hamm, head engine builder at Robert Yates Racing Engines. Gentlemen, welcome. How y'all doing today?
Hi, Brad.
Doing great. About you, Brad?
Doing fantastic. This is going to be a lot of fun. So, David, let me start with you. Let's just talk about your background a little bit. Robert Yates Racing Engines, just to sort of help set the table for sort of the background that we're going to be talking about here today.
Okay, my background, I started out as growing up in Charlotte, North Carolina, which was all about racing and wrestling, is all we had when I was a kid, and NASCAR was where it was at. And so I would hang out with dirt track racing and the local dirt tracks around Charlotte. And I got really interested in the engine side of it. I saw my dad watching one of the guys over there tuning up a car at a dirt track. And I said, you know what? That's the way I want to be. And from time to time, he would talk about seeing Robert Yates going up and down the road, drag racing down 74, Independence Boulevard, Wilkinson Boulevard, and Franklin and Gastonia. And so I got really interested in that. And so I decided to go to a General Motors automotive service educational program at Central Piedmont Community College. And the whole time I told them that's what I wanted to do, was get into NASCAR. And they said, well, are you sure about that? You got to know somebody. It's really hard to do. And I said, well, that's what I want to do. So fast forward, worked at dealership, Independence Boulevard, and then ended up getting to know some of the guys over at Sabco back around 1994, the Kyle Petty Mellow Yellow car. And they ended up, got me an interview with, Jeff Hammond first, and then I got an interview with Barry Dodson. And I ended up getting a job there in a machine shop. And so I worked over at Sabco for 6 years, a machinist, and I started building engines for the Cup Series in 1997. And I've been with the Cup Series pretty much ever since. Worked for Carl Wagner for 1 year. I worked at Bill Davis Racing back in 2002 and 2003. Part of 2003. And then whenever we won the Daytona 500 with Ward Burton, and then ended up coming over to Robert Yates. I got the call asking if I wanted a job. They were hiring an engine builder. They didn't normally do that. They would hire someone, they would move people up typically, but they hired me, and that's the best move I ever made. We're going to work for Robert Yates.
That's really cool. All right, Dustin, tell us a little bit about your background in Daido Metal, and kind of help set the table for what we're going to be talking about here today.
Sure. So my name is Dustin Kull. I'm an account manager for Daido Metal USA. I was hired back in 2016 specifically to expand the North American racing and aftermarket business. So, we started out with about a small amount of the NASCAR Cup engine business, and since then we've expanded through. We have about 95% of the NASCAR market now for engine bearing supply. We're selling through multiple big distributors in North America now, And, we're targeting everything from drag racing and top fuel and the nitro market, grassroots motorsports through, a lot of the dirt markets, sprint cars, modifieds, our focus is on bringing Daido technology, materials to a lot of these grassroots type motorsports, and give engine builders like David here opportunity to improve the engine reliability, performance through technology that we have to offer that nobody else in the market does.
Well, and obviously you guys have a very great and proven and respected track record, which is fantastic. I mentioned something at the start, Dustin, that we're going to be able to talk about some things that we don't typically talk about when we're talking about bearing technology. Can you expand on that? Because I think this is really a great learning opportunity and a great opening of the books, if you will.
Yeah, so, and not only just bearing technology, but really just engine development in general. And for us to be able to present a case study like this with such, from my experience, kind of profound findings and improved performance, with performance, race customers, engine builders, a lot of times, this information is very confidential. In this very specific situation, because Robert Yates Racing is the exclusive provider for the NASCAR spec engine. That spec engine is pretty much open source. Anybody can go and buy one of those engine packages. So the development, the findings that we have in this study are pretty much free to share. So in order for us to be able to collaborate with Robert Yates, compile this data and be able to share it, I think is a very unique experience. Not only just because of their reputation and their history in NASCAR and in racing, but just in general, to be able to share this kind of data, I think is unique, and I'm very excited to share today.
Yeah, what a great opportunity. For those of you watching us live, if you have a question for either Dustin or David, feel free to type it into the chat at any time. Again, this is your time. We want to be able to talk about what you want to talk about, just as if we were at a trade show. So if you have a question about what we're covering, jump in at any time. Please feel free to do that. So, Dustin, I know we want to start with a little bit of a PowerPoint presentation that we're going to kind of weave in and out of and talk about. So I'll let you take that over if you would.
Okay. Yeah, I've got about 9 slides today, so we'll start going through that. Like I said, we'll kind of bounce back and forth, and let me see if I can get her started off here.
Yeah, no problem. And again, as we're going through the slideshow and the PowerPoint here, if you have a question, please, again, feel free to type it into the chat. All right, we can see that, Dustin.
Okay. Is this the full screen?
Yeah, let's see. It's not full screen because we can also see the side part of it as well.
Apologize for that. Let me,
or at least the notes side of it. How about that?
yeah, let me try one more time here.
Yeah, no problem. I'm not as adept at PowerPoint, so I don't know that I'm the best one for advice. We do see your screen share.
There we go. How about that?
Now we have your Zoom screen, or at least your, there we go. Now we have it just like it should.
Okay. Technical difficulties resolved. All right, so yeah, let's just start out. So this case study is presented by Daido Metal and Robert Yates Racing. And we are presenting enhancing performance in NASCAR engines, case study on Daido Metal bearings with Robert Yates Racing Engines. And you see here a beautiful picture of the Robert Yates spec engine. So the introduction of this study. This case study investigates the impact of Daido engine bearings on the performance of Robert Yates Racing Engines NASCAR spec engine. This study was designed to isolate the effects of the bearings by keeping all other engine components unchanged. Testing was conducted using Superflow dyno to measure key performance metrics. The results demonstrated significant improvements, including reduced bearing wear, increased oil pressure, lower oil flow. These outcomes suggest enhanced durability and efficiency, with higher oil pressure improving lubrication effectiveness, reduced oil flow, minimizing parasitic losses, and less bearing wear, indicating greater longevity under high-performance racing conditions. Findings highlight potential of Daido's multi-boring technology to optimize engine performance in NASCAR applications without requiring modifications to other components. And one of the key things that I do want to highlight here is, again, kind of relating back to the grassroots racer and the opportunity that we have to share this information. The Robert Yates spec engine is based off of a Chevy LS architecture. A lot of these findings that we're presenting here today can be applied to any race engine that's ran in North America, anywhere, and especially with the LS architecture. So our main objectives in this study: improving the performance, evaluate the impact on engine performance, and one of the other key things was using Daido's performance aftermarket bearing sets. So this was not a bespoke design that we went and designed a bearing specifically for this. This bearing set that's used now in Robert Yates Racing Engines, this was a combination of our history in racing, NASCAR, and all of our technology that we built these parts for an aftermarket set. So these are sold through our distributors. Robert Yates distributes these parts to their customers. And then we also distribute these same parts through our other distribution partners, such as like MotorState, SRI, Callies. So I do want to make that point. Some of the key findings: 22% increase in average oil pressure, and up to a 48% decrease in oil flow, which is a huge point that we definitely want to you'll hear me repeat it probably 50 times over this podcast. And again, the scope of this project: the NASCAR spec engine, which is based on the GM LS architecture. We utilize the Daido performance aftermarket bearing sets, which incorporate new technology, such as the assembled thrust bearing, Daido's proprietary boring process developed specifically to reduce oil leakage at the main bearing parting line and improve efficiency. So definitely want to start out by giving you guys some background between the two companies as well, for those of you that are not familiar. Daido Metal is a longtime manufacturer. Daido Metal was founded in 1939, I believe. It is a Japanese company. And our bearings are used the highest levels of motorsports internationally. We have over 80 years of experience. We are involved in racing as high as F1, MotoGP, World Endurance, World Rally, Motocross, IndyCar, NHRA, and NASCAR, and many, many others. You'll be hard-pressed to find a internal combustion engine that Daido has not had their hands in. So
nice.
We're very, very proud of that. David, why don't I let you go ahead and give some of the history about Robert Yates?
Okay, so Robert Yates is, and I did a little cheat sheet here because if I start talking about Robert Yates, I'm going to end up spending about 30 minutes and going down so many different rabbit holes. So I figured the easiest thing for me to do was to print out something that I can just strictly read from and try to stay on chart on the. All right, NASCAR Hall of Famer Robert Yates was a mainstay in the stock car racing, both in the garage and engine shops that produced his trademark horsepower. We all knew about Robert Yates and his horsepower. To all the other teams that I worked with, that was always the benchmark for us to head towards. That performance yielded 77 wins as an engine builder and 57 as a team owner in the Premier Series competition. Unfortunately, we lost Robert back in 2017. He was only 74 years old, but his legacy lives on through his son, Doug Yates, and Robert Yates Racing Engines, and the countless people that knew him and worked for him and with him, including myself and Robert Yates Racing Engines here where I am. Yates launched his career with Hamm and Moody Racing, Ford's factory-backed team, in 1967, setting a path towards partnerships with some of the sports legends. Yates worked under the hood of Junior Johnson's owned machine for driver Cale Yarborough in 1974. Yates later joined the DiGard team, forming one of the sport's most powerful forces in the 1970s and 80s. Fellow Hall of Famer Darrell Waltrip was a cornerstone of that winning combination, netting 26 victories from 1975 to 1980 in DiGard equipment. I would tell a story about Robert. I would tell him I would ride my bicycle by a DiGard shop, and he'd say, "Did you hear the engines running?" And just get excited like that. And I was like, "Yes, of course I did." That was always a cool thing. I just lived right up the road from there. DiGard's success continued through the early 1980s with the driver Bobby Allison, Yates, and other crew chief Gary Nelson. Allison won the Daytona 500 in 1982 and took the series championship the following year with Yates horsepower guiding the way. 1987, Davey Allison won his first race at Talladega, also followed up that year at Dover and with Robert Yates horsepower. He started his own engine business in the mid-1980s and transitioned into team ownership. When he bought 1998, he bought Harry Renier's operation, officially became Robert Yates Racing in 1989. The young next generation star Davey Allison figured prominently into the team's rise, including a trip to Victory Lane in July 1991 at Daytona International Speedway. Robert Yates was as hands-on as it gets as a team owner, still going over the wall, changing tires, a jack man, which aspired to be like him. And he was also a truck driver. A lot of people don't realize that about Robert. He would drive the truck around. As a team owner, that's unheard of, but Robert did it. He did it all. Davey Allison won the NASCAR's All-Star race in 1991. As you probably remember that, Brad. I was there. And I was there also in 1992, the one hot night with Davey Allison and Kyle Petty there wrecking at the last lap. Victory celebrations were common in the 90s and Daytona. McGrath served as the crew chief there. Less than a year and a half later, Allison tragically died in a helicopter crash, of course, at Talladega. He was only 32. And fast forward to 2004, Roush Yates Engines began with when Jack Roush forces. The championship in 2004 was the following year. I started in 2003, and then in 2004, it was whenever it formed Roush Yates, and that was the best thing that ever happened, I believe, in my career, was to join forces and to win so many races through the years, hundreds of races and poles and the truck series, the Xfinity, and the Cup series, all. So now Robert Yates Racing Engines, the exclusive NASCAR spec engine supplier for the NASCAR Wheel and Modified Series. And we began this shop in, was it 2001, I believe, when Robert started this. So
that's pretty incredible. That's pretty incredible. All right, Dustin, well, tell us about some of this bearing technology. This sounds very exciting.
Yeah, so moving on to the key technology that was implemented in this study. Number one is the ID boring. So if you see in this little graph over on the right, these are 2 profilometer measurements. The one on the left showing the sort of traditional bearing boring method, which incorporates a machining process called a crush relief area. That machining process was originally designed and developed a long time ago, and it's specifically to reduce or eliminate the risk of parting line contact under extreme housing deformation, or if you have if the cap will shift on either the rod or the main housing. Now, back in the day, that was a much more common issue, especially with materials and machining technology was not where it is today. That was something that was very important you had to protect against. Fast forward 30, 40, 50 years, machining technologies, material technologies, all of those are so much better, and especially in race engines. So we have designed a boring method that removes that crush relief area, but we still have some protection against the cap shift housing deformation. It allows us to both protect the engine and reduce a huge oil leak, specifically implemented at the main bearing. And then the second thing is what we call the Daido Eco Lug, or the DE lug. Some people call it the race lug. So it is a locating lug, which is a very common feature, just to locate the bearing during assembly. The DE lug is actually pressed from the top side, from the parting line area. So there's no intrusion on the ID surface. So it allows you to maintain a better oil film throughout the 720 degrees rotation of the crankshaft, or the combustion cycle, and eliminates an additional leak path towards the parting line. So that's the main technologies that were implemented here, that we're kind of promoting in this study. Also, one of the important things, so our A to B comparison that we'll show on the next couple of slides, the same vertical assembly clearances were used, so nothing was changed there. All the same components were used on the engines. It is a true A to B comparison of just the traditional boring method to Daido's aftermarket or performance aftermarket parts that are available now. All these results were measured on a superflow dyno after the break-in procedure, and the on-track validation was completed, an evaluation of the parts to confirm the results and any wear and the visible inspection of the parts. So getting to the big numbers. So as we look through this table here, the column on the left is the measurement items that we're focusing on. You have the traditional bearings, the measurements with Daido bearings, and then our percentage of change. So under the same conditions, the oil pressure measured between peak torque and peak power from each power pole is how we calculated our average oil pressure, oil flow, power, and torque. As you can see, the traditional bearings, our average oil pressure was 68.7 psi. With Daido bearings, that increased to 84 psi, so 22.5% change. And we see that translate almost exactly over to the maximum oil pressure, 72 maximum oil pressure with traditional bearings, 88.6 psi oil pressure with Daido bearings. And then we can move down to the oil flow. We can see a huge reduction in oil flow. And now this all comes back to the elimination of that crush relief in the main bearings. So all that means is you're wasting less oil by leakage out of the main bearings. And that's really what all this technology is about, is efficiency and improving that oil pump capacity. Now, with that oil leakage and the improved efficiency, we can see that translate into power, even on this scale. So as we're looking at the power and the torque output, we see an average power output increase of about 2%, which isn't a huge number, but traditionally, changing an engine bearing is not related to a power adder of any kind. So of course, it's kind of a nice unintended consequence of what we were doing here. So and it also validates the improvements in efficiency that we're looking for. So moving on to the next slide. Oh, little malfunction here, I think.
That's all right. Here, what I like about this is you say, traditionally you don't talk about bearings as adding power. A lot of the things we talk about when it comes to adding power is adding something. you're using bearings anyway. So if you can use the
Right.
ones that are going to give you the most, again, that speaks volumes of the technology that you guys have developed.
Right. And, it's a common, it's a common hurdle, right? For, as a supplier, the competitors' bearings are, and the design, that traditional design has been used for so long. From the supplier standpoint, it is hard to get people convinced that there is something better out there. And that new technology is improving. And so again, this case study and this collaboration with Robert Yates, and such a prominent name, with their reputation, I think helps us tell that story of why we're doing what we're doing, and trying to provide these improvements to the market, to race engine builders. So yeah, this slide here is really the meat and potatoes of everything, of all of our work. One of the things that I want to point out on the power curve. So the dotted line is the competitor bearings, and the solid lines are the power pole with the Daido bearings. And what is obvious that sticks out at the beginning is the obvious power increase at low RPM. And all that we're seeing there is efficiency. That's reduction in parasitic losses, and reduction in windage. That is allowing the engine to make more power at lower RPM. And of course, looking at the graphical representation below of the oil pressure and oil flow comparisons, and that reduction in oil flow validates the improved efficiency and the reduction in windage, which is giving us that better power curve.
That makes sense. That makes sense. David, do you have anything to add to this as far as, what you guys are finding? And again, with Robert Yates Racing Engines building the spec engine, this is obviously getting a lot of use out there under the same conditions as well.
Yeah, I would add to the if people don't understand what Dustin means by windage, it would be sort of like, I was trying to think of an example that you could use, but let's just say if there was a boat in the water and the boat's going along, let's say it's a tugboat with the big most of the bottoms inside the water, in the water, and it's pushing along and it's taking a lot of horsepower to push that boat along, versus a boat that has the type of bottom that comes to a point and the point comes out of the water and it's just streamlining across the top of the water. That's sort of like what oil does when it hits the crankshaft and the rods, and it's hitting it and it's sort of like slowing it down just a little bit, and turning it into spray and all kinds of stuff going on there. There's been, stories in the past where smoking eunuch having a oil pan with the glass windows on it where he can watch all that and see how to reduce that, So that's what windage basically is.
Mm-hmm. That's pretty interesting. And when you start to talk about it, if you would, and I know we have a lot of people here who know a lot, and we do have a couple of questions from the chat. But when we talk about increasing oil pressure and decreasing oil flow, why is that more efficient?
So when you can increase, if you have a lot of oil flow and there's so much oil being pushed out by the bearings, and then it's getting in there and causing windage, for one thing. The other thing is, if you can control the oil pressure, you can typically run, let's say, a smaller gear on the oil, or a bigger gear on the oil pump. You can spin it a little bit slower, and that you can tend to make get some horsepower advantage there. One example of that would be back in the old restrictor plate racing days. Well, I guess they still have it in a way, but you'd see a power steering pulley on the front of an engine about this size. And that was just to reduce the amount. You didn't need as much power steering. You could reduce as much horsepower being dragged from the engine. Also, if you're driving around in your street car and you got a 4-cylinder, you can feel when the air conditioning kicks on, the air conditioning compressor kicks on, it takes a little bit of horsepower away from the engine.
Yeah, I like that description. All right, we have a question from the chat, and either Dustin or David, whoever is better, it says, why is the torque line on the competitor bearings higher at 6,500 to 6,700 RPM? if the Daido made more horsepower. So I know the Daido comes in and is higher at the peak and all of that, but how would you answer that question?
You want that one, Dustin, or me? I mean, a lot of times whenever you increase your horsepower, you might lose a little bit of torque. It's just sort of the way the power curve works. Do you have anything to add to that, Dustin?
Not specifically. Under peak torque conditions, and it's hard to say. Yeah, David really would have more experience than I would. After you cross that peak torque condition, it's hard to say exactly what is affecting the peak or the torque levels at that point. So it's combinations of, basically the efficiency is kind of maxed out in terms of oil flow, and I would say we've seen the maximum benefits after that point of what we've done with the oil pressure, oil flow. And that's why you see the power curve, horsepower curve start to come together at that point as well.
Mm-hmm. Yeah, that makes sense. Another question: have you found similar gains with your cam bearings, SBC configuration?
Not necessarily. So cam bearings are very different because they are a round bushing. So you don't have a sort of any sort of crush relief or machining feature that is an unnecessary bleed at that point. What we have done basically since we compiled this study, one of the other things that we're working on is Daido has a cam bearing set for the LS, and what we're playing around with is trying to reduce the clearance at the cam bearing as much as possible, obviously without introducing any sort of seizure risk. But that reducing that clearance is also reducing the bleed and the oil flow through the cam bearing. So if your engine is healthy enough where you can start to play around with that, you've got a good enough machining process where you can keep the run out in the housing as low as possible and really fine tune that cam bearing clearance, you'll start to see a very similar output as this as well. So.
Okay. And there is one more question, and you definitely can't address this too much. Where can someone purchase the bearings?
So as I mentioned a little bit earlier, Robert Yates is distributing these with their other components with the NASCAR spec engine. We're distributing these parts through SRI Performance down here in Mooresville. They're available through Callie's and through Motor State Distributing.
Okay. This is an interesting one. I know you have a couple more slides, Dustin. Does the reduced oil flow change the cooling characteristics of the bearings themselves or the crankshaft / connecting rods?
We definitely can see under some and it depends on the severity, right? So there's a lot of different factors here that play into the amount of cooling compared to the oil flow. So it depends on how the oil is flowing through the journals and through the bearings. With these specifically, we see a very small change in oil temperature. And that's mostly due because the oil flow reduction is coming out of the leak in the huge increase in clearance at the parting line. So the amount of oil that's flowing that we're reducing is all just a big leak path regardless. So it's not, what that means is that oil is not being used to cool anything anyways. What we want to do is make this more efficient. We want to tighten up the clearance near the parting line, remove that crush relief area, and maybe even open clearance to get more, to promote more oil flow around the actual journal itself, which then improves your cooling on the journal surface, on the bearing surface. So there's a lot of little factors here that all play into what we're looking at. And the key point also that when we'll get to, I'm sure I'll harp on it again, but what that means is the engine builder can do more things with that oil pump capacity. You can add piston squirters, you can add more oil to the top end of the engine. It allows you to do more things, open up bearing clearance. It just gives you more capacity with that oil pump to cool more things, to improve the performance. Or like David Hamm already said, you can actually reduce the oil pump capacity, right? Reduce the overdrive on the oil pump to further gain power improvements just due to reducing that parasitic loss. So lots of different things that the improvement in efficiency allows the engine builder to do.
Could you run less oil, like a smaller pan or anything, or would that not be advisable with this?
Well, that again, I think that depends on the oil that's being used, how the oil is being cooled. If it's an engine that has a large oil cooler, maybe that's possible. Marine applications where it's a water to oil cooler, maybe those situations you could actually run overall less volume in the engine. That's sort of a different problem to look at, but definitely what it does is it allows the engine builder to take a more technical approach at what that oil is doing and how it's being used and distributed throughout the engine.
Awesome. And I know you have a couple more slides, so I want to make sure we're able to get to everything.
Yeah, sure. So let's go ahead and move along here. So this is the validation after, I think this was a 4-race engine. So you can see the pictures on the right here. And these are a lead indium construction, which is why it has that light silver color compared to the more common lead tin copper, which is kind of a brownish color. And then at the bottom here, you can see our axial trace, which this is done on a profilometer. And we can very accurately measure here the highest amount of wear that we see on the edge loading here is about 5 microns, which is about 2/10,000ths of an inch. So and edge wear, especially on race engines, is very, very common, especially when you've got an engine that's revving up above 7,000, close to 8,000 RPM, and in a lot of cases much higher than that. Crankshaft bending is very common. It's very, very difficult to completely eliminate that edge loading and the edge wear. So we feel that this is very, very good results.
Most definitely. And that's a great visual to show exactly what we're talking about here.
And then just the conclusions. So to sort of reiterate, the increased oil pressure is achieved by reducing that leakage at the main bearing, ensuring better oil film retention, and does provide additional oil to the rod bearing. Because as you're not leaking oil out of the main, it helps promote oil flow to the rod bearing. The reduced oil flow, the Daido ID boring reduces that excess clearance near the parting line, reducing the leakage at the main bearing. And the increased power is due to reducing that windage and reducing the parasitic loss, freeing up horsepower. So again, to reiterate, what this means to engine builders is the oil pump capacity is increased. So we can relocate that oil, whether it's additional piston squirters, larger piston squirters, flooding the top end of the engine to cool valve train. Lots of different things that can be done here. Or again, reducing oil pump overdrive to reduce even further parasitic loss. We've had customers who've experienced very similar results to this study, who've been able to reduce oil viscosity, which as a lot of many engine builders know, probably all of them should know, reducing oil viscosity definitely equates to more power. So that's always something that is on everybody's mind. And these are all conclusions that are not new to Daido either. These are the same technologies that we use in many OE applications. Daido is one of the largest, if not the largest, OE supplier in the world for engine bearings. And that same ideology to improve efficiency, whether it's for getting better miles per gallon or just improving efficiency of an engine overall, all those same technologies help improve power and reliability in race engines.
I like that. Another question, and I know we started this talking about, because this is used in the Robert Yates Racing spec engine, these are results, this is technology, these are things that you can share that aren't proprietary to a specific engine builder or manufacturer that you're working with, which is great. So the question is, does the full line of Daido's race bearings utilize the reduced parting line area system, or are they specific part numbers? So if I want this technology and I'm not getting a Robert Yates Racing engine, but I do want to get these bearings, what's the best way to go about asking for them?
Yeah, that is a great question. So our strategy for all of the aftermarket or performance aftermarket parts, so anything that is a V bearing, which many people know is equivalent to like the old Vanderbilt lead indium. We kind of stuck with that market terminology. Any of the Daido V bearings, the main sets will have the what we call multi-boring, right? So it's that reduction or the elimination of the crush relief. The rod bearing sets, for aftermarket rod bearing sets, we have not introduced the crush relief elimination for at least the performance aftermarket. Again, basically once the oil gets to the rod bearing, it's at the end of the line, right? So it's got to escape the rod. And so we want to, by leaving the traditional crush relief there, we want to sort of promote the oil flow through the rod. The oil or the connecting rod condition is usually much more severe than the mains anyways on pretty much every racing application. So we want to promote that oil flow and the cooling through the rod bearing, and that's why we've maintained the sort of traditional boring method on the rod bearings.
That makes sense. So David, if I told you, here's a really easy way to find a couple more horsepower, another foot-pound or so of torque, and increase efficiencies to where you could start moving oil into other places, how appealing would that be to you?
Oh yeah, that's very appealing. That's why we ended up going to the Daido bearing, and it's been very beneficial for us. We've been able to do a few more things. We've actually opened up our rod bearing clearance a little bit. That's helped with some of our cooling in the rods and things. And as Dustin was saying about getting the oil flow out of there, but it's definitely because the parting lines, the rods, everything's coming back looking really good. The rod bearings, main bearings, all that stuff. So we were really appreciative to it, and we plan on moving forward in the future with it.
Yeah. And look, I'm always thinking about the end customer as well. Obviously, we want power. We want all the things that are going to help us win races and everything. But we also want something that's reliable. And we know that you guys built a lot of reliable engines over at Robert Yates Racing Engines. But still, now if you've got another thing inside of that, another component that is going to help that, what does that mean to the end user? What does that mean to the racer?
What was that question again, Brad?
Like, what does it mean to the racer to be able to have something that, with all the efficiencies we've talked about and all of that, look, you can't always get power and you can't get longevity out of that power. Sometimes you can find that magic thing. And I talk about that a lot. It feels like that.
Well, I'll tell you one thing it means to the racers. Any racers nowadays, especially, are all about saving money. And it's not that Daido costs any more than anything else. It's very comparable in price. And so if you're going to make those improvements and go with a better bearing that's going to perform better and last longer, and it's going to save you from having to spend, another $10, $20, $30,000, halfway through the season, then most racers are all for it. So that's probably the best thing for the racers, to save money and to have performance.
Well, and the other side of it too, with Robert Yates Racing Engines, connecting with suppliers like this, like with Dustin and with Daido and all of that. Again, that's one component that goes into your engines. I know you guys are doing that with everything that goes into building an engine, but just having these relationships, if you could speak to how important that is.
Well, it's been huge that I've been able to, if I had a question about a bearing, if I had one that I was questioning, why did it look the way that it did, and maybe trying to make some improvements, that type of thing, I just pick up the phone and give Dustin a call, and he has the answers for me. I can send him pictures. They can get the analysis done for bearings that we've run through a full season, and tell us, ways that we're always looking to make, improvements. Of course, that's just in our nature, is to always try to improve everything that we do. And that's how you end up making horsepower. You put all those improvements together into one package, and you come out on the dyno with the best horsepower possible.
Yeah, for sure. Yeah, and Dustin, the other side of that, you can do one thing in a lab. The best lab is actually what happens on the racetrack, right? And with that relationship with Robert Yates Racing Engines, you get to see all of that.
Oh, 100%. It's definitely the my favorite part of this job. So yeah, anytime we get to collaborate with a company like Robert Yates Racing Engines, it validates everything that we're doing. So all of our experience from rig testing and our technical center over in Japan, when we can take all of those analysis and put it into an engine and see the real world improvements, it's such a great feeling, and really strengthens the relationship, I think, and hopefully helps the reputation.
Well, Dustin, we don't always get this. We don't get, someone like you being able to share like you were able to with this. And David, it's great to have you on here as well. Great to catch up with you again. And we really appreciate both of you. Thank you.
You too, Brad. You should consider doing this for a living.
Thank you.
Yes, sir.
Thank you both. What a great webinar, and thank you, Dustin, for putting everything together, and David for joining us today. This webinar has been recorded. It will be posted later on the EPARTRADE platform, distributed through our newsletter channels and our social media channels. In the meantime, we push Daido Metals back on the homepage of EPARTRADE. So for more information and update, please visit epartrade.com. We're going to be talking engines again next week with J. Dickens Racing Engine. So thank you very much, and see you soon. Bye-bye.
Thank you.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from EPARTRADE.
EPARTRADE is a digital platform that we've created basically to make life easier in the business community of auto racing.
EPARTRADE, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
EPARTRADE really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components, circle track, drag racing, and any top race shop? In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crower Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crower Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crower Cams provides the muscle you need to dominate. And with Crower, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.